Let's solve triangle ABC. If angle A is 60 degrees, angle B is 75 degrees, and side C is 10 meters. When you are being asked to solve a triangle, that means you have to find the measures of all the angles and the lengths of all of the sides. In this problem, I'm given the measure of angle A and the measure of angle B exactly. I'm given the length of side C as 10 meters. It's often useful to draw a diagram when solving a triangle. So I'll draw a triangle here, and it's certainly not drawn to scale, but I'll label the vertices A, B, and C, and then fill in the given information with 60 degrees and 75 degrees for angles A and B. And then side C, realize that in the naming of a triangle, side C is directly across from angle C. So the side that I've been given as 10 meters is side C directly across from angle C. Side A is directly across from angle A, and side B directly across from angle B. The easiest first step in solving this triangle would be to find the measure of angle C. Angle C can be found using basic geometry. The angles in a right triangle add up to 180 degrees. So if you know two angles and you want to find the measure of the third angle, you can subtract the two known angles from 180 degrees. In this case, 180 minus 75 minus 45, or minus 60 rather, is 45 degrees. Angle C is exactly 45 degrees. The lengths of side A and side B are a little more difficult to find. To find those, we're going to need the law of sines. The law of sines is a formula from trigonometry that states that sine A, the sine of angle A, over the length of side A, that ratio, is equal to the sine of angle B over side B. And both of those are equal to the sine of angle C over side C. The law of sines is usually written as three fractions set equal to each other, but when it's actually applied, you're going to take any two of these. To use the law of sines, you need to know, as a starting point, you need to know an angle and the side across from it. You need to know what an angle measure is, and additionally, you need to know the length of a side directly across from it. So I either need to know, to start with the law of sines, angle A and side A, angle B and side B, or angle C and side C. And based on the work that I've done so far, you can see that I know angle C and side C. And that's actually the only pair of angle and side that I know. I don't know side A and I don't know side B. But the fact that I know angle C and side C, that's enough for me to get started, and that's what I'm going to use to find side A and side B. I'll begin by finding side A, although the order doesn't matter. I could find side B first. To find side A, I'm going to start out by writing down the ratio of the angle C and side C, sine of 45 degrees, angle C, over the length of side C, which is 10. That's the sine of C over side C, sine of angle C over side C's length. I'm going to set that equal to the sine of angle A over the length of side A. Now, I don't know what the length of side A is yet, but you can see after I've written down this equation that there's only one unknown. This is an equation known as a proportion, but in this equation, A is the only unknown. You can solve a proportion by cross multiplication. I'll take the sine of 45 times A and set that equal to 10 times the sine of 60. This equation can be solved in just one step. I can divide both sides of the equation by the sine of 45 degrees. And that means that A is equal to exactly 10 times the sine of 60 over the sine of 45. This is an irrational number, but it can be stated as exactly 5 times the square root of 6. The length of side A is 5 times the square root of 6 meters. When using the law of sines, you'll usually, when using the law of sines to solve for an angle or a side, in this case we're solving for a side, you'll usually get an irrational number, and depending on the problem or the level of precision needed, you can round this off to any number of decimal places. In this problem, I'm going to be rounding off to 2 decimal places for my unknown sides. 5 times the square root of 6 is approximately 12.25 meters. I'm going to find side B in a similar manner. This is not a right triangle. I can't use the Pythagorean theorem at this point to find the third side, but I can use the law of sines to find the third side. When I use the law of sines, I'm going to again start with the sine of 45 over 10. I could start with the sine of angle A, 60 over 12.5, but that 12.25 rather. That wouldn't be ideal though, because 12.25 is not the exact length of side A. It's approximated. I'm going to use sine of 45 over 10, the sine of angle C over side C, because that information is exact. That was exact given information. And I'll set this equal now to, instead of the sine of angle A over A, the sine of angle B over side B. I have a very similar equation. It's actually the exact same equation, except the numerator of the second fraction is the sine of 75 instead of the sine of 60, but it's solved the same way. I'll cross multiply. B times the sine of 45 is equal to 10 times the sine of 75. Again, this equation can be solved in one step. I can solve for B in one step by dividing both sides of the equation by the sine of 45. Again, this is an irrational number. It can be stated exactly as 5 root 3 plus 5, but rounded to 2 decimal places. Side B is 13.66 meters. Now that we have the measures of all of the angles and the lengths of all of the sides, we have solved this triangle.